Let's look at an example where enums might be useful. This is a class, direction, that has a private constructor, which means the only instances of direction that exist are the ones created within the class. There are 4 instances, north, east, south, and west, which are accessible via these public constants. Here's how direction might be used. This is a record coordinate, which is just an xy pair. And inside it's got this method, adjacent coordinate, which takes in a direction and returns the coordinate in that direction. The problem is the compiler doesn't know that there are only 4 directions, so it's telling us here that we're missing a return statement. So we need to put some code down here that can't actually happen. I'm sure that this isn't going to come back to bite us. Anyway, let's not worry about that for now and test out our method. Here we've got a coordinate 3, 5 and a direction east, and we're asking for the adjacent coordinate in that direction. We can run this code and see that we get the coordinate 4, 5. So everything's working. Now imagine that a few months pass and direction is being used all over our code base. The business comes to us and says, we want to support some more directions. We want to support northeast, southeast, southwest, and northwest. So we go to direction and we add in these new directions. We update some of the places that directions used in the code, but we forget our coordinate class. What happens? At first, the program might appear to be working correctly, especially in a large and complicated code base. But eventually, somebody's going to try and pass in one of the new direction values into our adjacent coordinate method, and then we're going to get a runtime exception. How can enums help? Let's rewind a little bit to before we added those extra directions. We can replace the direction class with an enum. As I mentioned before, enums are special data types that only allow a predefined list of values. We define an enum by placing the enum keyword right here where the class keyword normally is. And then inside the body of the enum, we just list all of the values that it can take. We write them in all caps because they're constants. Enums can contain other things too, like constructors and methods, but we'll get to that in a little bit. Believe it or not, these 4 lines of code do everything that our previous direction class did, and more. Java implements equals, toString, and hashcode for us. All of our old code still compiles, but we can do better. You can use enums directly inside switch statements, and as of Java 14, switch expressions. We can replace the implementation of adjacent coordinate with one that uses a switch expression. This is both more concise and also removes that annoying assertion error that we had to put in before. You've probably guessed what I'm going to do now. Let's add in those new values of direction and have a look at coordinate again. The compiler is telling us that we're missing branches on this switch expression. What was a runtime error before becomes a compile time error. It's literally impossible to make the same mistake. Enums provide a couple of other nice features, which I'm going to explain in a second. But first, if you're enjoying the video and you want to see more like it, please subscribe to the channel. Enums automatically support the method valueOf, which converts a string to the enum value. This can be useful when handling user input or interacting with a database or something like that. Enums also implement the comparable interface, which means that collections of enums can be sorted, or they can be used as keys in sorted maps. Here's another enum, importance, which is listed in decreasing order of importance. Enum is silently implementing compare to for us. We could add implements comparable to the enum statement if we wanted to make future maintainers understand that we're depending on this property, but in practice people rarely do this. I've created a simple record here, task, that has an importance and a description. We can create a priority queue of tasks by telling the priority queue that we want to order the tasks in order of importance. If you haven't seen priority queues before, don't worry, they work a lot like lists, except they allow you to access the smallest element really fast, regardless of the order that you added them. If you want to see a video about lists and queues, then drop a comment down below and I'll get to it. So we have a priority queue of tasks, and we add a bunch of tasks to it that have different importances. One at a time, we poll the queue for tasks, and Java gives them back to us in order of importance. The important thing to remember is that we never implemented the compare to method. Just by declaring importance as an enum, gave that to us for free. Let's take another look at our direction enum. If you think of enums as syntactic sugar that implements a lot of the boilerplate of a class for us, then you won't go too far wrong. That means that we can add extra methods to enums if we want to, just like we would with a class. All we have to do is put a semicolon after the list of values, and then we can provide our methods just like normal. For example, here's our method next direction, which looks at the current direction, this, and returns the next direction along the compass. In fact though, because directions in Enum, there's a better way of doing this. Enums provide the useful methods, values, and ordinal that help simplify this implementation. Values is a static method that returns an array of all of the values that the enum can take, in the order that we listed them. Ordinal is an instance method that returns this value's index into that array. So to implement next direction, we just add 1 to our current ordinal, and then make sure that it lies within the bounds of the array. There's just one more aspect of enums that I want to explain before we wrap up. Since enums are just syntactic sugar over normal classes, they also have constructors. For example, this direction enum has an implicit private constructor with no arguments. I can type it out to make it explicit. IntelliJ is telling me, hey, you don't need this private modifier. That's because it's kind of the whole point of enums that there's only a predefined list of values, which means that the constructor has to be private by definition. We can't allow other people to create instances of direction. So I can go ahead and remove this unnecessary modifier. You can see I've also added in these brackets after each value of the enum. That's because when the enum's created, each value calls the constructor, and at the moment it's calling it with no arguments. This isn't strictly necessary, and normally you wouldn't see this, but I'm just doing it to show you that each value is calling the constructor like this. So, say that we decided to add a field, degrees, which would be the number of degrees on the compass that this direction is. We can do that by adding a parameter to the constructor and adding a field just like we would for a normal class. I'm just going to go ahead and do that. Here, I've added the degrees parameter to the direction constructor, and I'm storing it in a private final field here. I'm giving access to it via the getter, and you can see that I've just added in those degrees values into those brackets after each value of the enum.